based out of our India office at Hyderabad. I have a total of 10 years of experience, 10 plus years of experience, and I've been with Progress with more than since 7 years. During this course, I was involved in various product lines that we have in Progress. Most recently, I've been working in the development of our cloud product called Pacific since the last 3 years. I'm very fortunate to be associated with the cloud development team from the very beginning, and it has taught me and our team a bunch of lessons which I'm going to share now. Okay. To give a short intro of what Progress as a software company is, Progress Software is a software platform provider company. Most of our big customers are mostly ISVs, independent software vendors, who actually use our platform to develop applications which are core to their businesses. Our flagship product is called OpenEdge, which is there in the market since 30 years, and it's on the on-premise world. It's actually a 4GL language which lets you develop desktop and web-based applications pretty fast. Recently, we also added support for mobile web business application development, while enabling our customers to reuse their business logic which they have already written and running on OpenEdge. And some of the brief background. So Pacific is our first venture in the cloud. It's it's an APaaS. It's basically an APaaS. If you know what APaaS is, application platform as a service, which lets you build web and mobile applications pretty quickly through almost no code. Like you can drag and drop from a WYSIWYG kind of an editor and develop applications, and it also lets you run those applications in our hosted environment. So basically, we give the complete package where you can develop, deploy, and run the applications on our cloud platform. In addition to that, we also provide all kinds of connectivity solutions that let you connect your business applications to a variety of data sources, including cloud data, new emerging cloud data sources like Salesforce and Dynamics, and also the on-premise data sources where you have all the data in. So, yeah, so that's all I want to tell you about our company and products. The reason why I spent a little time explaining about the company is to give a background of what type of company Progress is. Traditionally, which we are good at delivering on-premise products, and it is our first venture into our cloud. So it's not that we have a lot of in-house experience to build on. So we are almost like a startup starting a cloud project. So we had a pretty good development team. So through our course of development, we build a pretty stable and solid cloud product. And through this journey, we made some mistakes. There are some lessons learned, so which is what I wanted to share with you this next coming 2025. In the next coming 50 minutes. Aside from the technical aspects, there's also a cultural difference in the way we develop cloud applications, which is very different from developing on-premise applications. The mindset of the developers or the QA engineers, it should be different when you are developing applications for the cloud versus on-premise. So this will be perceived across different phases of development, like development, testing, including especially during the monitoring of the production systems, the way you react to the problems and things like that. So it's been a challenge for us as a company to gain the cultural shift from the on-premise to the cloud world. I do feel we have learned a lot in this aspect and did a pretty good job at it. Having said that, I don't think we are there where we wanted to be. There are still many things we have to improve. So it's an ongoing process. So we will be using the experience that you have built on to make our cloud platform even better. So I hope some of these insights will be useful for you in your efforts if you are building cloud-based applications, and I hope you like the content I'm sharing with you. For more information on progress and the products, you can visit our website, which is www.progress.com and progress.com/product/specific. Okay. So today's agenda is pretty simple. Um, I don't believe in theory. I mean, you can sit and you can sit and explain a lot of things to your people, but it doesn't register. What I believe that registers well is a set of stories or incidents that you can relate to your daily to your environment. So instead of going through a list of best practices and why are they important, which most of us probably already know, is I decided to give you a bunch of incidents that have happened during our voyage of building the Pacific applications and the lessons we learned from them. And finally, we'll just summarize the lessons in one slide and take it as the thing to remember from this 1 hour talk. Okay, so without further ado, let's get started. I'll start with something called as dependency analysis mayhem. So as you can imagine, our platform is it's a pretty big platform, and we have divided the platform into a bunch of services that interact with each other, as well as external systems like identity provider, ERP systems, and things like that. So to just to give a context of the deployment of how these services are being deployed in our environment, we have one web server where we have multiple of these deployed. But it is not necessary that they have to be in the same thing. Each service we have developed is independently deployable. If you want to scale out one service or further, we have that flexibility. So we did a pretty good job at dividing the application into a bunch of reusable services. So that worked well for us. But as our platform kept on maturing over a period of last 3 years, we had most of our desired functionality inside the product, we started concentrating more on making the product secure. So we started investing on things like whatever information that you're storing on disk, which includes like the username, passwords that you're probably storing in the properties files or even database, or even the PII sensitive information, which is PII data that you're storing in database. We wanted to encrypt that. So we took on that initiative, and we had to do the dependency analysis of what all services will be impacted when you say modify the sensitive data of one backend table. Though we did a pretty good job of separation of services, what we actually didn't do well is that we let services use the database a bit freely, in the sense if we felt that accessing the database table is much easier than calling some other service, we went ahead and build queries on top of the database so that we got the required data for that service to work. For example, say we wanted to show email in the UI. So UI is a service, and we have a user service for getting it. Instead of UI service calling email from the user service, we actually wrote a direct bypassing the user service. We actually wrote a direct call to the database to get the information. Now, the problem we had is to figure out what all services got impacted when we were modifying the database table. That was really a big mess, and in fact we missed quite a lot, and thankfully, because our application matured, we had a good set of regression coverage. We are able to figure out the dependencies in our testing before we moved it to production. So, but the whole experience as such is not the best one. It is not very is not a very good one for us. So obviously we wanted to fix a situation. So its solution is actually pretty simple. You make the database schema, which is related to a bunch of service, part of the service. Let no other service interact with it, and let the services interact with each other rather than directly going to the database. So this obviously should have been the motto from the beginning. We did that at the services layer, but we didn't do it at the database layer, which costed us. So I thought I would share that experience with you. So we made some progress in it. I don't think we have completely done it. We are doing in a module by module fashion. So I hope if you're building your applications now, cloud-based applications now, or you already have built some applications and you have some leisure time to do a re-architecture, you should consider doing this. So there's a term for it in the software world. They're calling it as microservices. You can Google it for more information. But essentially, it means you divide our application into a bunch of services and let services interact with each other. It does help you a lot in the long run. You should also make sure the database schema that belongs to the services is part of the service and nobody else should use it. Of course, it's a good to have. We cannot have a hard and false rule as such that nobody else should use it. Exceptions will always be there. Example, if you're using a reporting tool, they most likely hit the database there than calling the APIs that sit on top of the database. If you're developing an application from scratch, you don't get much time to build the API layer on top of the database, especially for reporting. So maybe the reporting tools will directly hit the database. So whenever there is an exception, there's an exception, but that should be a conscious choice rather than just an ease of implementation. Like if I make this choice, it makes my life easier. So that shouldn't be the motive for breaking this services architecture. That's the first thing I wanted to share with you. Okay. Moving on. So the next is mostly a lesson from our business requirements. So whenever you're developing applications on the cloud, you should also think of how the application will run in a private cloud or an on-premise scenario. So you don't have to make sure it works on on-premise version, but you should ensure that you don't introduce dependencies when you're developing the cloud application that makes it impossible to make it run an on-premise version. This especially is matter to us for Pacific because we are a platform company and somebody wants to host our platform in their own data centers. So we had to be private cloud enabled. So also having the both hosted cloud solution and private cloud solution your solution will be more amicable for business than if you just have only a hosted cloud solution. So in order to do that, you should ensure that the services that you are interacting and the systems you are interacting are replaceable. So if you are, say, using one system for authenticating your users, you have to make sure that you have enough provisions in your applications to replace it with something else. So this should be part of the original design and thought, the original design then an afterthought. So that should be kept in mind when you are architecting the application. If you use API first way, like you build the API first and anything that needs to be orchestrated, which is a UI or a process, should be done on top of the API. So if you follow that pattern right from the beginning, I think you should be good for the most part. And to ensure interoperability, you should use standard-based communication. Don't try to use any protocols that are proprietary. There will be exceptions, so it's a practice. So for example, you connecting to a database, use standard JDBC or ODBC, use REST and SOAP. I think more than SOAP, REST is now a standard. So use REST for interacting between your services and for authentication, use OAuth, SAML, and stuff like that. So try to use as much as possible standard-based communication. It is not always a case that you have a standard. Even though you have a standard, you always have exceptions that people don't have that follow that standard. So that case, try to abstract it through an API. So you talk to the API, and the implementation of the API can talk to any of the underlying systems that you want to leverage in the cloud. Most often, the main problem that we have faced internally is that we are on Amazon, and Amazon provides a whole bunch of other services other than their just infrastructure as a service. So if we directly use them, if we directly use their Amazon APIs in our product, then we have a problem of unplugging them when we go to the on-premise version or the private cloud version. So always build an abstraction whenever you're talking. I mean, it's not that you shouldn't use IaaS provider services, because the services are given to you at a with a bunch of benefits. Like if you want to build your own messaging system, it takes a lot of time. But if the IaaS is giving for you, why not use it? So make sure that you follow a standard, like say in case of Java, if it is, you should use JMS so that you can replace it with any other JMS provider. So whenever you're using any of the infrastructure provider services, make sure you abstract them through an API, or better use a standard protocol for communication. Okay, so that's about it. This is a bit of so in terms of our experience, private cloud wasn't the goal when we started the development. So it was made as a goal for us almost after a year of development. So whatever we had, but whatever new features that we are developing, we are ensuring that we will follow this pattern of using a standard protocol or an abstraction API. And also we are slowly working on repairing the things that we started using directly, any of the direct IaaS services. So that's about private cloud. So this is important. If you have known this from the very beginning, the way you approach the things would be pretty different from way if this were not a goal. But in most cases, I think private cloud would make sense. Okay. Guys, I'm not sure how to take on the questions. Do you want me to do it now as and when go, or I'll probably do it when at the end of the presentation? We'll have a brief period where we can do a Q&A. So I'm seeing some questions in the chat window, but let me just run through what I have to say, and then we'll take questions. Okay. Okay. Moving on, then the next thing that I want to share with you is the problem we had where some of the services that we have are intermittently not starting up. Like we have a bunch of services now, and then one of the service failed to start. So in the very beginning, what used to happen is that our QA should, after the deployment is being done, our QA would start the normal testing, and they find some functionality broken, and they will report it to the dev, and dev would go ahead and debug and see that one of the services that should actually do that piece of functionality didn't start. So this was intermittent, and because we didn't have lack of reproducible steps, we ignored it. And we had a very good workaround that if you restart the service, it used to work. So this is way at the very beginning of the initiative, very beginning of our development of cloud platform. So we kind of ignored it because I mean, you don't get the luxury of spending time on debugging intermittent issues when you are developing a lot of functionality for your application. But it used to waste a lot of engineering time, both from the development and QA. Then after a while, it started. The problem started not so intermittent. Like instead of say one in a week failing, we are finding it more often. Then we said we had to do something about it. So what we came up with is this. For each service, what we had is a kind of a status endpoint where, if you can call it, the service would say whether it's up or not. And we have asked our DevOps team. DevOps team usually takes care of our deployment to make sure that they run the status endpoint for all the services. Only if they are all successful, you the build to QA as a working build. So we kind of shifted the problem from the cycle of QA reporting, dev reporting to DevOps, and this worked for us quite well for a lot of time. But the underlying point is we still didn't fix the issue. We're still having the problems of services being intermittently failing to start. So after a while, we once we have got enough stability in our product, we got some time to work on this, and we went back and looked at and found the root cause of the problem. What was happening is each of our services has a database, has a pool, connection pool that connects to the database. Now, whenever each of the services is initialized, obviously the pool is initialized and a bunch of connections were made to the database. Now, initially, when we didn't have so many services, I think this was working fine, but as and when we started increasing the number of services that we had in the product, so this was just not scaling. So eventually we hit the connection limit of the database. We could increase the connection limit on the database, but that's not the right solution, but we're just postponing the problem. So also we had a ELB behind 2 instances. So like we had 2 instances of the same server running in 2 machines. That means there's twice the number of connections that you're making to the database as in 1 machine. So it was just not scaling. So that's it. We found the root cause of the problem. Then what we did was this, which worked well for us, but may not be the best possible solution in all the cases. But what we did was, instead of having each service have the connection pool, let's the connection pool be shared across all the services that are running inside the server. So this worked pretty well for us. There is a drawback with it, in the sense if one of the service is resource hogging, the other services won't get it. But in our experience, we didn't find that problem. All the services seem to run normally. We didn't have the connection starving problem. So this solution worked well for us. This also has a drawback, in the sense that there is a bug in the code for the connection pool, that whenever it's initializing it, if it is not able to get the database connection, the server itself didn't start. So we went ahead and fixed the code for the connection pool library, and so we let it start. As and when it gets the database connection, it starts to function. It tries to get a database connection. If it doesn't bother. It still starts the server and all the services. And if at all at a later point database connection comes back, it connects to it. So now everything is working well for us. So based on this experience, the lessons that we have learned is that resiliency is very important, especially when you have an application system which has a bunch of services that are interacting with each other. Resiliency is very, very important. So each of your services should start up, even though the dependent services are down at the time they are starting up and they are not reachable. So you should make sure every service starts. You should also make sure that the services should continue to function if any of the dependent services are down. Say if for some reason database there's a network error and you cannot reach database. Even in that case, the service as such should work. I mean, it could throw exceptions saying I cannot do my task because I'm not able to connect to database or whatever. But it should function and it should respond to the request that it is getting to. And finally, if dependent service goes down and comes back, the service should connect back to it and everything should work normally. The seems obvious, but it is not easy to implement. You have to make sure that all these 3 points are taken care in every service that you are actually having, and you have to do it for every endpoint that you're making a connection to connect to a different system. So resiliency is quite important. We learned that. We made all our services resilient, and that has helped us a lot. And the second thing is you should use connection pooling, especially when you're trying to maintain a dedicated connection. So, but you should tune the connection pooling to your requirement. So you should ensure that you tune the connection pooling. You shouldn't ignore that. And finally, don't ignore the intermittent issue. It won't hurt you in the long run. This lesson we have learned from multiple issues. We kept postponing, saying things are intermittent, but eventually they ended up hurting us. Like some process or the other used to fail in production. That was already reported as an intermittent issue in our testing phase. So don't ignore intermittent issues. Obviously, you have to prioritize. So based on the business needs and the prioritizations, whenever you have time, please spend time on fixing or debugging the intermittent issues and what is the reason behind them. So something or the other is usually wrong. Okay, so that's about that. Then the next one I wanted to share with you is about the issues that we cause because of a non-responsive system. So this is just a bloated diagram of the previous one. We have a web server and we have a service, and service has multiple endpoints. So each of the endpoints, say, assume kicks off a process which does, say, multiple tasks like task 1, task 2, task 3. Task 1 is probably validating credentials, going to the database. Task 2 is calling some other service within your own application. Task 3 is calling out to an external application, and finally task 4 is writing to a database, something like. You will always have a process like this whenever you have a request, and obviously since it's if it is an API based application, you will have concurrent requests hitting to your endpoint. So what happened is that in one of the flows, the system that we are talking to is an external system, and it was not responsive, in the sense it's not down, it is up. You don't get a 404 or anything. It's a HTTP request. You don't get a 404 not found or anything. It is up. The call has been made, but unfortunately, since obviously the other system is also a software, it had a bug, and whatever call we are making, it went to an infinite loop and it never returned. The call never returned. We had a timeout for the call, but it was pretty high. I think it was 5 minutes or so. So what happened is that all the requests that you're getting for that endpoint started hanging, waiting for the response from that system. And eventually, obviously, as and when more requests start coming on the endpoint, web server couldn't take more, and our service started responding that it cannot serve more requests. So there's nothing wrong with our system, but the point is there's something wrong in the other system which made our system look bad. So this is a lesson learned for us. So what we did, there are a bunch of ways you can solve this problem, but the most important thing is you should have a sensible timeout for every outgoing call in your services. In every request that you're making, you should know what is the expected or the worst case expected time, and you should break after that. Otherwise, something or the other in your system will get affected. So what we generally tend to do is for every, say, outgoing request, I have a timeout of, say, 2 minutes or 3 minutes. So try not to do that. Try to have it, say, per system that you're interacting. If it is, say, a profile server, you have one timeout. If it is, say, another ERP system, you have to have some timeouts, things like that. Maybe you have it per system. If you can better have it per endpoint, like the depending on the API that you're calling, if you can have that timeout, it's great. That is the best possible solution. The other way of solving the same problem is to use the messaging instead of making a synchronous call. You can make an asynchronous call and let the messaging system take care of the delivery. It's not always possible. Like in our case, it has to be a synchronous call, otherwise the process would fail. So all we can do is to reduce this timeout to a sensible level so that our services would start responding in a reasonable time. Another related issue around this non-responsive system is that we used to get the connection reset issue for some calls making that for some of the calls that we're making out of the system. Connection reset usually comes whenever there's some exception making the connection for the first time. So we tried to debug, we worked with our internal IT to figure out if there are any network glitches at that time, but didn't find any. Most other requests happening at the same time were going through. There's no nothing wrong with the network. The call we were making was to a third-party vendor or OEM vendor. We logged a ticket with them. We asked them to investigate if they have any network issues. We got a similar response. Their network issue is fine. Then it turns out that connection reset was a bug in our HTTP library that we're using. So we changed our library to a higher version, and it fixed the problem for us. But if you look at the same problem from another point of view, whenever we got the connection reset, it was not in a critical path. Say some read-only field in the UI won't be displayed, so that's probably fine. I mean, if you reload the page, it would have worked. The same call, if you have done the second time, it would have worked. So another sensible thing to do is to implement a retry. Whenever you have the issue. So it also depends on the type of call that you're making. So having a retry strategy for the calls that you're making outside the system will also help you. Okay, so those are the things that we have learned from this experience. And I guess this is probably the last one. I'll share it with you. So this is a this is a massive thing, and we did learn quite a few things from this experience. So what we have is, whenever say a new user signs up to our Plastic platform, say evaluation, and he signs up as an evaluation user, we send a message to messaging broker here, and we have a client which reads the messages of the broker and send it to our lead management system. Thus, that system takes care of following up with the user, see what he's doing, whether he's got stuck in any of the issues and he's not able to proceed and things like that. So there's a bunch of process in lead management system. So there should be a data flow from our platform to that system. So we could have done the direct way, but we choose to do the messaging way as shown here. So what happened was, after a release, the connection from our platform to the messaging broker was fine, but the connection that the client makes to the broker was for some reason terminated, and it goes back to the point I made. We haven't made the messaging client here resilient by that time. So if the connection is lost, it was not retrying to connect to the broker. It was just sitting idle and nothing is happening. And then like 1 week after the release, our lead management system people contacted us saying, and they said, we are not receiving any leads from your system. What's happening? Are there any users signing up or what? So we debugged and we figured out there's a problem. So as a fix, for that solution, we restarted the client, and the client made the connection back again. So everything was working fine. and we closed the issue. And later on, we went ahead and actually made the messaging client resilient. That's a different thing. But and we said the issue is fixed. And a couple of days back, a couple of days after, the lead management people came back to us saying we're still not getting the leads. So what happened now is that the connection or the information flow from platform to the broker and the client is fine, but the flow between the messaging client and the lead management system was broken. This was because we actually configured a wrong lead management system endpoint for the messaging client. So we should have expected the system to reject our messages, but it was silently consuming the messages, so we didn't knew anything about it. So it was returning success saying it processed it, so we thought the message was delivered, but unfortunately that was delivered to a wrong system. So what to do? So the message from our standpoint is successfully delivered, but it is not delivered to the right destination. Fortunately, we had the actual message stored. We didn't lose the message that was actually published from platform to the broker. Even though it has been consumed, successfully consumed, we stored it for keeping reasons, and we have a separate archival policy that helped us. So we went back, we saw that we picked up all the records that were successfully sent, and then we wrote a simple program that would read from the storage and put it back to the broker so that the messaging client would send it again. So we corrected the configuration of the broker to the messaging system, and we resend all the messages that were stored in our database back to the broker. And so fortunately for us, there was no data loss. So there were a lot of lessons that we learned from this experience. The first thing I think we already covered is resiliency is important. Something is not making a connection back to the service it's supposed to connect, you will have a problem. You should fix resiliency issues. The second thing, you should have enough monitors to ensure that all the systems that need to connect to each other are connecting properly. So that you should derive from your logs, log information, which I'll talk in the next step. The third thing is that even though we successfully processed the message, we still had a retry mechanism of processing the same message again. That helped us. So don't make sure that you have an offline retry policy for something that you want to, even if something is already done, make sure that you can redo it again. So just ensure you have an offline, a separate tool that can retry the same, retry the process which was done successfully previously. So that actually helped us. And the last is pretty important, which is the configuration to the connection configuration that say the messaging client has to the lead management system and the broker. It's not dynamic. We had to restart the client to pick up the new credentials. So if I were to design it right now, the configuration is not, it's not hard-coded or something, it's actually externalized to a properties file. There's nothing wrong in it, but unfortunately in a cloud environment, the properties file sits in the machine where the service is running, and you make some modification. Usually the properties file is read once. If you make some modifications to the properties file, it won't be picked up until you restart the service. So unfortunately we have that problem. So the lesson learned is you should have the configuration dynamic, in the sense the services, if there is any change in the configuration, the services should be able to pick up the configuration, new configuration, and work with it. There are multiple ways of doing it. We have done it for few things. So Like for example, all the messages that we show in the UI for us are dynamic in the sense you can change it in one place and it automatically gets reflected. You don't have to change, you don't have to redeploy or anything. So we have done that for some of the services. We haven't done for configurations for some of the services, so we're still doing it. So dynamic configuration is a big thing, and you need to make a conscious effort to make sure that your services can pick up the configuration dynamically. And finally, hopefully I'm not taking too much time. Finally, I'll talk about logging. Apart from all the other things I talked about, those incidents that we faced, logging is a standalone thing. And like logging, the approach for logging in an on-premise application versus cloud applications are different. This is what I talked about. I meant about the culture of the development and the QA team with respect to the development of cloud applications. Unlike in an on-premise application, usually in a cloud-hosted version, you have the logs available to you almost real time. That's a big advantage, and you can push changes to your applications very fast compared to the on-premise world, and that's one of the advantages of a hosted cloud application. So, and you should make use of that advantage by improving logging in a very iterative way and doing very useful stuff with logging. So there are many cases where we found issues with our logging and fixed it, and it tremendously improved the quality of the product that we have. The way we monitor it, the way we track the exceptions, the way we find the problems where they're coming, the way we react to the problems, things like that. So it helps a lot, immensely. It helps immensely. So I'll share some of the incidents that we found, that we had some logging problems and the way we fixed it. So for example, if we go back to the previous diagram, where is it? Sorry. I should have copied over. If you go back to this diagram, you see that at the endpoint we are getting a multiple requests, and each request is performing a bunch of tasks. So all this, so we can have, so we had logging, we have enough logging to say that it was doing task 1, task 2, task 1 was successful, task 2 was successful, and so on. So that was all fine, but the point is, since it writes to the same file, so there was no way we can, and you are getting simultaneous requests, there is no way to correlate what log message is for what request. So the log messages are all jumbled with each other, so it was not able to, I mean, it was almost impossible to figure out a flow for each request. So one way of solving that is to have a unique identifier, say for example a user ID that is there as a part of the request, and log it for all the individual tasks. We did that, but that also didn't help because it helped a bit, but it didn't solve the problem completely, because if you get the same, if you're getting a request from multiple systems for the same user ID, again you have the same problem of jumbling. It probably not to the same endpoint, but probably to a different endpoint of the same service. And it all writes to the same log file. Then you have the problem of jumbling log statements. So what we did is we introduced the concept of request ID. So we introduced the concept of request ID. So whenever we get a request for any of our endpoints, we create a unique ID by ourselves, and we log it with every message that will go from the start to the end of that request, so that we have one bunch of correlated log messages that we can work with. That helped us a lot in figuring out what's happening in each of the flows. The second is actually following up from the first one, which is to correlate the request from multiple systems. For example, we are getting a request from one of the service within our system, and that is going to another service. So we want to see how the flow of events is happening between the services. So each of the services are logging their own request ID. There is no way you can correlate with just request ID. So what we added is a concept of correlation ID, which is probably there in most specific brokers. So every request you can pass in a parameter, additional parameter called correlation ID, and we would ensure that we log that along with our request ID, so that if you give the correlation ID, you can see what's happening with that request across different services. So that also helped us a lot. In fact, it was leveraged cleverly by QA automation. Like if every QA test case that runs from our automation generated a unique ID and passed that as a correlation ID. And if that test failed, we can just search with that ID and we know what happened for that particular test instead of going through a huge bunch of logs to figure out what's happening. Other thing is we are as I said, we are a bunch of connected services, and whenever we're making a service request to another system, in some cases it failed. This was like way back in the beginning, and it failed, and we were not logging the request and response, and we reported the failure to the OEM. We are making a call to our OEM vendor. We reported the failure to them, and they were not logging the request response either. So there was no way to debug it. I mean, we had literally no information to debug the issue further. So we immediately fixed that. So whenever you're making a call to an external system, we make sure that we log the request and response, especially when there is an exception. Not every time, especially when there is an exception, we log the request and response. So that helped us a lot. Logging also helped us in setting up a lot of alarms, which will help us on the system health status. I talked about the issue of services not starting up. There's another angle to it, like we were logging enough information so that we can poll if the service is actually running fine. So we set up a lot of alarms on it. If there are no log messages from that service, say for the next 5 minutes, raise an alarm. And we had the dashboard showing how many requests each service is processing and things like that. So you can do a lot with login. Of course, to enable this, you need to have a distributed logging solution. I think that is a must-have for a cloud product. So you should have a distributed logging solution which will enable you to do some sort of analytics from your log messages. And finally, it also helped us in doing the alarms. Also helped us in doing a productive support. Example, I think a couple of weeks back, we found out that one of our customer is trouble having updating an address in his profile, and that was actually a bug from our side. So the autofill of the browser is causing an issue. Whenever browser does the autofill, the country is not getting correctly sent. The value in the country is not correctly being sent from the UI to the backend. So we figured out that he was having an issue, and we proactively contacted them and said, look, we have an issue. Why don't you not use autofill and manually fill the information for the country, and you'll be all set. And yeah, things like that you can do. The proactive support when you have a real-time system of monitoring logs. There are many such instances where that helped us during the course. Like, I mean, logging is not a one-time activity, or like it's never done. It's an iterative process. As and when you learn new things, or you hit new issues, or you hit an issue that you don't know how to debug further, there's always a chance for improvement. And the biggest advantage with the cloud is that you can do that pretty quickly compared to the on-premise applications. So that's all. So I want to talk around logging, and I'll skip the next slide. I think I covered most of the points in here. So to summarize, summarize the things that we have learned is like follow the microservices architecture, divide the system into a bunch of interacting services, keep private cloud in mind when you're designing it. You don't have to develop for private cloud. Make sure private cloud is possible. Take care of resiliency. This is the biggest thing. Take care of resiliency between services. Use messaging, make use of messaging wherever applicable. It really helps. Modern day messaging brokers are pretty fast that you don't even see a lag between in-process call versus messaging. They're pretty quick. So use messaging wherever applicable. Dynamic configuration, make sure all the services can pick configuration dynamically. You don't have to restart. Take logging seriously. Log a lot. Don't overlog, but log a lot, log smart, log enough context so that you know what's happening when in the process of execution. And finally, not but not the least, don't ignore intermittent issues. I know you won't always get time to fix intermittent issues, but whenever you do, just go through your logs, figure out what are the least count exceptions that you have seen from the last 1 month or so, and then try to fix them. See what, or not try to fix them, try to figure out why they are coming. That will actually give you an insight of something wrong in your system. So don't ignore the intermittent issues. So that's all I have in this session. Any questions? So let me see, I'll just go from the start. Can you explain number 3 again from Harsh? Which slide was that? Can you give me more context there? And that's